Welcome to the role of machine learning for cloud-native performance optimization. My name is Brian Licasar. I go by Lico. That's why you see I've scratched it out there. And I'm the Global Director of Solution Architecture here at Stormforge. I've been a big fan and participant in open source for a long time. 25 years or so. I don't like to think about it, but let's just say I had a lot more hair back then. And I got my start by installing Linux off floppy disks back in the 90s. What I loved about that back then was that I could better understand how the computer was working, and I could even contribute to fixing the software, which was unheard of, if you can imagine that. I know here we are 30 years later. It's quite a different world, but that was a great manifestation of what I learned in computer science at university. So even though I work at a machine learning company, I failed statistics twice before I passed it. So there's my fun fact, if you will. But here at Stormforge, we use machine learning to turn observability into actionability to optimize Kubernetes workloads. So now I've got a much better appreciation for P99, if you will, or standard deviations and all these other fun things that we look at when we look at metrics and statistics and make those determinations. I'm a huge fan of theme parks, so you'll find me in the US and Florida and California often to visit either one of the real big ones. And I also am a proud father of a 13-year-old who inspires me with his insightfulness and curiosity. Been married to my best friend for almost 20 years now, and I have a lot of close friends I spend most of my free time with when I'm not enjoying live music, or maybe I'm enjoying live music with them. It's been great. One other thing that I've started the last 7-8 years or so is mentoring folks on LinkedIn. I think LinkedIn added an ability to offer that. I've been offering that since then. So ping me on LinkedIn and say, hey, I'd love some guidance on this. I'm happy to guide you in any direction. I'm a geek, but I'm also a business-oriented geek, so I'm all over the map as far as that sort of stuff goes. And if I can help, I'm happy to. I take great pleasure from that. Okay, so Kubernetes resource optimization. I'm a nerd, Kubernetes nerd here at Stormforge, and we are constantly working with our customers to get resource utilization right. We want to get it correct. And I have a personal passion for this because I'm tired of us repeating the sins of the past. For too long, it's always been this mentality. If you think back even to what we'll call bare metal systems, is we said, okay, well, we're going to just use this much ought to be enough. And that was always the answer. That was always the way that you approach it. And I saw that move into VMs. And again, with containers, it's just continue to repeat these sins, and I don't know why we can't be better about it. We have so many more tools at our disposal than we've ever had before. And it's all too commonplace for organizations to just pay for a lot of computing capacity instead of taking time to solve the problem, which is also frustrating, to say the least. And so I got real scientific about this, and so we asked on Reddit, what are your approaches or best practices to figure out your Kubernetes resources? And so we got variations of 3 different answers. You'll see some of them on the screen here as examples, mostly because I like the usernames as well. And that first variation is you have to write extensive performance tests for every microservice and then deal with the results and the data. Or you write your own tooling, and you have to code that, maintain that, and continually make sense of that output. Or finally, it's impossible. It can't be done. And I think when I read that or heard that, what I thought of it as is it's not that it's impossible, it's that it's not worth our effort, whether that's time or human resources to invest in this. The business isn't seeing enough benefit from it, and so they opt out of it or decide that's not something that they need to do. And especially as your environment reaches a certain threshold, it becomes a lot more unwieldy to keep up with this and do the right things and perform some of these manual tasks that often have to be done to get the best optimization or the right sizing of these pods and deployments inside of Kubernetes. Some organizations are already doing it and have blogged about it. So Airbnb put a nice detailed document on their blog about how they did this. One of the interesting things I took away from it, though, was that a lot of the savings that they saw was that they did some manual right sizing of their deployments, and then they were enabling cluster autoscaler underneath. Well, no disrespect to them, great work. I'm glad you did it. But the downside of this was you didn't have cluster autoscaler on, and frankly, it's only become more mature in the last couple of years to where that was useful to you. But you also had to do that effort of right sizing these deployments. And again, that can be very manual. You're putting a lot of onus on the application owners, perhaps, and maybe they don't even know what the impact or rationale is or what the right answers are, and I'll get more into that in a few moments here. Uber also did something similar to them, to Airbnb, but what was funny there was they have a paragraph in this write-up that they did, and it talks about how they could write an entire article simply on right-sizing their containers because it was such an arduous task. And again, I want you to think of these problems at scale, because realistically, doing any one of these in isolation isn't that big of a challenge. But doing them at scale, perhaps of your organization's scale, can be a lot to bite off. And that's what I want you to be thinking about as we chat here today. Finally, Pinterest spent a ton of time and energy into optimizing their systems. The one that they gave a write-up on is 35,000 pods, over 2,500 nodes, if I remember correctly. And a lot of that write-up, though, and a lot of the work that they had to do, strangely enough, was at the control plane level, or the Kubernetes API level, and including etcd. And while that's fun, I've done some of that stuff myself, I don't know that that's really beneficial for a typical business. In fact, most customers I speak with are using a cloud provider's environment like EKS on AWS that handle the control plane for you, and you don't have to worry about those details. That's up to them to solve and resolve and make sure it's resilient. And really, a lot of Pinterest write-up focused on those elements. Again, a common thread of all three of these, though, was that they had to spend a lot of time in getting the resource requests right, because if they're not asking for the proper resources, the underlying infrastructure is just trying to provide what it's been asked to do. It doesn't know, it's none the wiser. It doesn't understand that you, when you ask for 4 CPU but only need a half of a CPU, it's going to still try and give you 4. Or more, in fact, because that's kind of a bare minimum when we're talking about requests. So something to think about as you're approaching this. And then again, at scale, how much waste there can be across an entire environment. It's funny, if I may go on a tangent here, one of the things that I learned early on when I was first working in a corporate or a business world was you treat the company dollar as though it were your own. And with the advent of cloud providers and how popular they've become, a lot of that pricing is front and center to every user. It's not just the people who pay the bills, so to speak, but it's also those who are using the products and services offered by these providers. And so now it's even more apparent to you, at least, that, gosh, this might cost my organization thousands of dollars for the work I'm doing. Now, what I'll tell you, I'll speak to both sides here, interestingly enough, is that you weren't aware of it previously, and you might have been spending tens of thousands of dollars on behalf of your organization. And your organization was okay with that because the business received the results it wanted. So this was okay. But now that you're more aware of it, you're probably even paranoid. You're like, gosh, I'm wasting our company's money. Some of you also might have the attitude some of my friends have, which is cost of doing business, and they move on. I hope many don't have that. I'd like to be more efficient. And in fact, here at Stormforge, one of the things that we talked a lot about years ago was about trying to help with cloud computing waste so that we can make the world a better place. In other words, less energy spend on computing. So I don't mean to plug that too hard, other than to mention it's something we've all thought about, and it's kind of built into our culture here at our organization. But overall, not many, getting back to topic here, not many companies have the time, the teams, the resources to plan and execute the way that these three organizations have. Now, it's almost cliche to say that Kubernetes is complex to work with. However, if we look at the foundational items required in any running application within Kubernetes, we've already got 4 or 5 elements to consider. So you can look at CPU requests and limits, you can look at memory requests and limits, or replica counts as well. And these are all what helps inform us and how we meet our SLOs and SLAs for our organizations. We meet the needs of our internal customers or our business needs. But in my humble opinion, when you let this to an application team and you say, don't worry about any of these settings, just let the system handle it, that's where the problems can begin. And in fact, let me take that a step further and say they really need to start looking at application settings. So here on this slide, for example, I've pointed out some common Java-based settings. Now, please don't worry. You don't have to understand Java at all to understand my point here. My point here is that the settings that you make inside your application or inform your application's runtime can more strongly inform and impact the performance of that application and its resource needs. So what you set here then informs what you set in the container itself or in the pod definition or deployment definition. And those are most impactful oftentimes, at least that's what we found. But if you think about Java, as I'm picking on them, I'll continue to pick on them. When you think about Java, Java has over 50 different parameters for the virtual machine runtime to tell it how to run and what to run. And I know in the latest versions, it's much more intelligent about making decisions for the user. But I also want you to consider that this can really, really impact the way it performs. It may take more time upon startup, for example, to decide, oh, I want to use this garbage collection algorithm because this is the way you're allocating memory, or I want to do, there's so many different parameters. And in fact, I'll give you another observation I have based on a number of customer conversations, and that is heap sizes. And again, I don't mean to pick on Java, but it's quite popular. One of the things I've seen all too often is that an application group says, oh, my app's not working right. I'm getting an out of memory error or a heap size overflow or these sorts of things. And so they go to Stack Overflow, they kind of search for it on the internet, and the answer is, well, you've got to set your heap size. You have to set a higher minimum or extend the maximum or something like this. And so they go ahead and they do this, and maybe they set something arbitrarily high, and now their app works, they never look back. They never consider, well, gosh, setting it to 8 gigs was overkill. It doesn't need to be that high. In fact, probably could have just been set to 4 and would have been plenty. They never consider that, and so no one revisits this. In fact, we kind of wait for some sort of operational outage or SLA miss before we try to make this a better situation. So, with all these combinations and permutations of the parameters that you can look at, it's exhausting, frankly. It's overwhelming. So I see why it's easy to set these aside and just push forward and just ignore it. But ultimately, this complexity forces you to make a choice. So you can take the time and energy to sort out the proper configuration, which I like. I think that's good. Or you don't take the time up front and you spend it later, more inconveniently, maybe during non-business hours to troubleshoot performance issues because you can't do it during the production high usage part of the day. So you've got to back off and do it at a different time. Or maybe you do this on like a weekend. Like, I don't know about you, I don't have to work weekends today, and I love that. I relish that. But there's poor people who end up having to work weekends to do these testing during off hours if they don't have a test environment that they feel approximates their production well. It's so unfortunate, and I hate to see that. Or the final option, which I think is probably the most common, is to overspend on resources and keep throwing more resource at it for the application, assuming it will make things better. And let's face it, that doesn't always happen. So I wanted to quote Henning Jacobs. He's from Zalando, and he gave a talk at the High Load conference. So Zalando is the #1 retailer for apparel in Europe, and they run completely on Kubernetes. And so he kind of calls it out, and he says, so humans are adapting things in YAML files, but why isn't this automatic? Why can't we leverage that? And for them, everything they can do to improve performance is going to help them sell more. So it's real important to them to do that. Collectively, we've all heard a lot about artificial intelligence. And so everyone thinks that it's kind of a perfect solution to this. And frankly, that's what StormForge feels as well. I'll talk a little bit more about that in a second. But the whole idea is that it's helping us solve problems more quickly than humans could, maybe automating mundane tasks. Once you invest the time up front and have a framework and approach that you can continue to have the application running at its best, most reliable and predictable way with regard to resources, life gets better. That the hard work you put in, the investment up front, it reaps rewards in the end. It's like becoming much more familiar with your application without spending the years reading code or debating with your coworkers about what the app can do. So let's talk about some of the key attributes of machine learning driven optimization. So machine learning is only one facet of artificial intelligence, and it's something I feel can solve the problems we have. In theory, we've been capturing so many metrics from our observability platforms, but how often do we actually use that to solve the problem other than looking back and troubleshooting when we're in the middle of an issue and we have an outage or an impaired performance? Machine learning can be used to take action on these metrics and turn observability and actionability. Like, let's trigger something to happen when we see certain things occurring. And we have the basics of that, but I don't think that's widely implemented, and it's probably because it's a little more challenging than we anticipate. Cloud-native container-based applications have more abstractions than we've ever seen, and that can make it really tough to gain insights about what's going on. Machine learning is great at identifying patterns much more quickly than we humans ever could. Now, if you've followed news articles about artificial intelligence, you've likely heard a lot about biases. And a lot of times these machine learning algorithms just take their creator's bias and they amplify them and make it much more pronounced and prominent. In fact, I found that we can actually, to the contrary of what you've heard, we can actually fight against typical computing biases. So let me give you an example. For a long time, if you've been in technology any length of time, you've probably heard the answer to slow performance was throw resource at it, throw memory at it, throw CPU at it. In these cases, you're assuming the bottleneck is what you're putting more resource into. So that's a fair assumption, I suppose. But in current systems, you could actually have worse performance. Let me give you just a quick, silly example, but go with me here. Let's say we throw more memory at a problem. And it's, we think it's going to do the difference or make the difference, but we're not sure. We throw it at it. Simply by having more memory, there's a couple things that can happen, and I've seen this. The first thing that can happen is maybe the runtime of the application needs to be adjusted somehow to know to take advantage of that additional memory. Like it might not natively just use the fact that there's 20 gigs of memory now. It might not know to do that. Maybe it's got a default use limit of 8 gigs. I've seen things like this. Or maybe it counts on that as file system cache, which doesn't actually help your app because most of its data calls are actually I/O bound or network bound out to other systems that have the data that they're looking for. Also, the system itself, so kind of outside of the purview of the app, the system to maintain and manage memory and more memory takes more resources, can actually slow down the performance because it's spending so much time doing lookups of that memory, where those addresses are, these sorts of things, instead of just providing the resources in the memory straight to your application. So it's kind of funny how that ends up playing and working against you. Machine learning, though, has no bias in this regard. So if one of the things we've seen is setting some of these values lower than someone would ever consider doing based on their own biases. And what you do with like our system, for example, you get to set the ranges that you want a value to run at, and the machine learning will explore every corner of that range and define where we're getting the optimal result. So what can sometimes happen is we reduce a value that, again, as a human, you would never consider doing, but the machine learning tries it and finds that the throughput improved, the latency improved, whatever it is, whatever your goals are, and we would have never done that. So we tend to see people looking at these more for cost because it's about resource optimization, but sometimes these kind of unintended consequences are beneficial. And so it's kind of funny how machine learning can actually help us instead of harm us in that regard. Finally, automation is key. Have you heard that one before? There have been tools to run and rerun iterative tests before, but between these runs, a human would have to go and inspect the results and then make a maybe educated or somewhat educated guess as to which of the parameters that were adjusted actually made the difference and made things better. And this is only going to lead us back down the path of having biases in our data and biases in our approaches. And all the while, there's still a human factor where if that test finishes up after someone has finished their work hours, you now lose the overnight. So that's why automation is so important. By the way, if we have any people in the audience who are actually still running a lot of testing, especially performance tests by hand, I'm sorry, I appreciate what you do. I'm grateful you're doing it. I wish more people did that, but please work to automate it. Save yourself the frustration and strain. It's something I'm grateful for because it's something I don't see done often enough. It's usually ignored. This is a quick visual of what machine learning can do for us. I've got a common proof of concept that we run here at StormForge. Real simple graph here of cost and duration of a different performance test. And what we do between these runs of our performance tests is we adjust the parameters of the system under test. These are containers, and we inject in different values. And we tend to want to look at least 5 parameters simultaneously, preferably those application ones like I was talking about with Java before. So in this case, I've got a plot of about 40 different results. Now, the data points on here don't include failures. So if something fell out of spec, let's say that we wanted to make sure that the duration did not exceed 40 seconds, for example. Let's imagine that 40 seconds was the limit. We'll throw those results out. We don't even want to consider them because that was a failure. And if the cost ended up being over 100, then we don't want to consider that either. So these are only the successes here. What we're looking for are patterns in this. Now, there's starting to be some patterns here in our system. We'll put diamonds in place that show which ones it feels are the optimal results, but this is only based on 40 trial runs. That's not near enough. I see a few clusters forming here, maybe a few clusters here, but what we really want is for the machine learning to take some more time and run through the performance tests enough to get more certainty and have more data points. So as I move to the next slide here, I've got a lot more data points to consider, a lot more to look at. And you see a huge cluster in the bottom left. So we're really getting close to what you might consider the perfect one. In fact, the dark diamond is the one that the machine learning has decided is the perfect one because it's got the lowest value of both cost and duration. So we have more patterns that have developed over time. And this is where the machine learning is demonstrating that it's found the best results. It's an important thing that machine learning can do in its approach to performance optimization. It continually runs without frustration, because it's not human, towards the goal set. What's also interesting is that the plot points don't include, remember, none of the failures. So obviously in this case, we said it can go up to 90 seconds for duration. So maybe I was incorrect there. But no human time was wasted as it keeps going with these results. So hopefully I've made a reasonable case here to you about why machine learning could be really well suited to optimize Kubernetes workloads. And with that, please come chat with us in person. We'll be at KubeCon in Detroit in the US here the next week, the 24th through the 28th of October. And then you can also come speak with us at reInvent in AWS's conference in Las Vegas here in the US as well, near the beginning of December. So I'd love to meet you. I'll be at both of those events myself. And with that, here's my contact information. Please tweet at me at Lico9. Find me on LinkedIn if you'd like some mentorship. I'm happy to help you in any way I can. And you can always reach out to us at stormforge.io or me specifically, Lico at stormforge.io. With that, enjoy the conference. Thanks a lot for your time.